This presentation is entitled Reach and Grasp by people with tetraplegia using neurally controlled robotic arm. Tetraplegia is sometimes referred to as quadriplegia, a term used to describe the inability to voluntarily move the upper and lower parts of the body. The areas of impaired mobility usually include the fingers, hands, arms, chests, legs, feet, and the toes, and may or may not include the head, neck, and shoulders. What causes the condition of tetraplegia? Well, according to the National Spinal Cord Injury Statistical Center, vehicle crashes are currently the leading cause of injury, followed by falls, acts of violence, primarily gunshot wounds, and sports and recreational activities. The injury disconnects the brain from the body, eliminating the ability to perform volitional movements. The team has previously shown that people with long-standing tetraplegia can use a neural interface system to move and click a computer cursor and to control physical devices. They experimented with able-bodied monkeys and used the neural interface system to control a robotic arm. But it was unknown whether people with profound upper extremity paralysis or limb loss could use cortical neural ensemble signals to direct useful actions. They hypothesized that a neural interface system could restore mobility and independence for people with paralysis by translating neuronal activity directly into control signals for assisted devices. The tools that were used is they selected 2 people with long-standing tetraplegia. They also had the neural interface system-based control of a robotic arm to perform 3-dimensional reach and grasp movements. They also had micro-electrode array implanted in the brain to decode signals from the local population of neurons that controls motor function and send it to a computer for translation. Here are some graphics. Here is the graphic of a robotic arm that was made by the company Decker. On this side, we have the experiment with here are the arrays that is implanted into the brain. Here is the robotic arm, and here where the arrays is planted in the brain and connected to the computer, which in turn send the signal to the computer, send the signal from the computer to the robotic arm, and the robotic arm here is being used by the patient to drink coffee. The results demonstrated the feasibility for people with tetraplegia years after injury to the central nervous system to recreate useful multidimensional control of complex devices directly from a small sample of neural signals. The result also show that the brain, once the brain is intact, it can be used to transmit signals for various applications. And here is a link to a YouTube video that has a demonstration of what we are speaking about. The implication of this study, it has the ability to restore mobility to other parts of the body, also to perform other tasks. A neural interface system can be used to help the elderly, for instance, to operate devices. The study has some limitations in that the use of industrial robot arms come with the need for an expert in how they operate the system. They also need constant monitoring from the experts. There's also the fear of job loss. It's also limited that robots are not creative nor innovative. It also has not been extended to use in homes, and it relies on wired connection. In the future, it can be developed to use to restore body movements. For example, other parts of the body, for instance, if you lost a limb, they can use the same technology to attach it to your arm, and the arm will be able to perform the function directly from the signals from your brains. And it also has the potentials for wireless control. Instead of connecting the wired from the brains to the computer to the arm, it can be done wirelessly in the future. The use of prosthetics is also widely speculated that it can be used in this area. Here are some references. Thank you.